Hi, my name is Gabriel, and I will be your host for this session. This session is called Automated Terminal Naming with SUSE Multi-Linux Manager for Retail, Scalable approach. And in this solution, we provide a way to automatically create fixed addresses for stores on SUSE Manager SUSE Multi-Linux Manager, and I will talk about this in the next slides. Okay. So first of all, I want to introduce SUSE. That is the company that I work in Brazil, and in SUSE we specialize in cloud infrastructure, automation, and enterprise software solutions. And our goal is to help business to optimize their IT environments efficiently and securely. And from the very beginning, we have been an official SUS partner, and we provide these SUS solutions for our customers. And also, frequently, we deliver software together with SUS solutions to deliver highly reliable and innovative solutions to our clients. Our expertise extend across enterprise ID, modernization, DevOps, Kubernetes, and also open source solutions, many open source solutions. And we help business transition to these modern architectures. In addition, we provide consulting, implementation, and managed services to support organizations. And our mission is to simplify and optimize IT operations, focusing on efficiency, security, and cost effectiveness. And now let's explore a little about SUSE Multi-Linux Manager for Retail, and then later we can talk about our solution for naming host names. So the agenda was the introduction. Also, we provide an introduction about SUSE Multi-Linux Manager for Retail, and specifically the POS control, naming control. We discuss how SUSE Multi-Linux Manager helps manage and automate the naming of point of sale terminals in retail environments. Following that, we will dive into configuration reactor module for automatic fixed naming and IP assignment for POS. And later, we will cover the aspects of these solutions and do a little live demonstration. In fact, it's a recorded demonstration because it's a very huge demo. Yeah. So with the video, we can skip to the important parts, and you can see how the things work on this environment. Okay. And then later we'll take a look of the codes for this automation, and later we'll give to you a link on GitHub to get the code, and maybe later you can discuss directly with me for more details. Okay, so let's get started. The SUSE Multi-Linux Manager for Retail is a variant for SUSE Multi-Linux Manager, and the main idea is to provide a centralized management for retail IT environments, enabling organizations to efficiently handle their infrastructure. So you can use SUSE Manager Retail for manage POS terminals and other types of terminals, inserting operation. You can create Linux image, customized Linux images for these environments. You can deploy system in various scenarios, from remote provisioning to offline installations. You can automate updates and patching, and also monitor the system health across the company. Okay, and later but not less important, you can detect non-compliant systems, preventing security risks. It's good to compliance environments in the retail. Frequently, we have financing transactions, so it's important to be compliant. And what is the terminal naming management? So for retail environments, we have frequently thousands of machines. Okay, it's kind of normal to have thousands of machines inside a big retail company. So the terminals are assigned to specific names across the infrastructure. This helps to create an organized and structured environment where every device is easily identifiable. So proper name management is essential because it prevents conflicts between terminals and simplifies the POS device administration. Without a structured naming system, duplicate or inconsistent names can cause issues in device communication and configuration. And to solve this, SUSE Multi-Linux Manager for Retail allows dynamic and automated name assignment. This ensures the standardization and control, making it easier for IT teams to manage this infrastructure without any manual intervention. So let's explore how SUSE Multi-Linux Manager achieves this through the architecture and automation capabilities. So this diagram illustrates the architecture of SUSE Manager for Retail. In the first layer, we have the SUSE Manager Server. I'm sorry, this is old architecture from the manual of SUSE Manager. And this is manager server is responsible for central management. In the second layer, we have the branch servers. And the main idea is to have branch server for each store. Okay. And also we have a build host to handle the management of the images and deployment tasks to transfer those images to the branch servers. In the third layer, we have the POS terminals, which are the actual devices used on retail stores. And the idea of this three-layer architecture is to provide more consistent architecture to ensure scalability and reliability inside the store. Okay, so it's a efficient system to update the systems across multiple retail locations. The branch server can handle the traffic if the SUSE Manager server is down or something like that. Okay, so the idea is to provide naming for the POS terminals. It's because those terminals use one automated image, and then the terminals are registered on SUSE Manager, and when they are registered, they get one name. You can configure the terminal name inside inside the formula on every branch. So the types that you can configure on SUSE Multi-Linux Manager is the HW type based name. The names are derived from the terminal MAC addresses and also from the type of the hardware. Okay, naming by hostname. This technique is to use the terminal unique ID. Frequently, it's a ID generated on the first boot process. So these use the first four characters of the machine ID plus the branch server name also. and you can use a predefined hostname assignment. So you can use a predefined list of hostnames, and also you can use a hostname for a MAC address, but it requires a manual updates on the branch salt formula. You have a salt formula on every branch, and then you can set the HCP on those branch servers, and then you can define a host name and also a MAC address with a fixed IP address for each machine. Okay, so the advantages of have a automated model, it's the key benefits that you can reduce errors in terminal name assignments. You can speed up the provisioning process, making the deployment faster. You can simplify the management, requiring less manual intervention, and you provide a scalable way for large retail networks. You can ensure it smooth expansion for those retails environments. However, when using a manual naming approach can be challenging for huge retail environments, and we addressed a problem to manage like 1,000 stores on this big environment that we use the when you use this approach for a customer. Okay, so when you use reserved names using host name reservation and also MAC address, you need to create some records manually. Okay, so frequently in retail environments, we have to use a fixed and a sequential name for the POS. It's easier to device identification and also to identify the location of each device. And the current method in SUSE Manager is used to use fixed addresses, but it's totally manual. It's and the customer asked to us or say to us that this process increases a lot the administrative overhead. The interface is a little bit complex, and it's harder to manage for a large number of devices. Okay, and also to maintain a numerical order of the host is challenging because the formula interface does not have order bar or some filters that can help the user to arrange the order of the POS hosts. Okay, so let's see a new process that we deliver for this customer. So the first of all, we have the same architecture image. So in the first time when POS boots for the first time, it will receive a dynamic address from the HCP. Okay, and then the terminal will use this IP to register on SUSE Manager server. So in the second step, the terminal is registered, and then SUSE Multi-Linux Manager will fire some states to get hardware information and package information and in things like that from this first boot process. And then we used a reactor to get these profile events in Salt bus, and then we use a reactor to fire automation on automation server. We used a new server to run those automations because we want to not interfere on SUSE Manager or SUSE Multi-Linux Manager processes, and also to not interfere in process that can broke the SUSE support. Okay, so then we used this reactor to fire automation events on the automation server. In the third step, the reactor fires the state on automation server, and the automation server uses the SUSE Manager API to reserve a slot for this new terminal, and can fire in the automation server also fire some events on the branch server and also on the terminal. So it uses the SUSE Multi-Linux Manager API to manipulate the formula data on the branch server, and then later it calls a state to persist those these formula data on the branch server, and later as the last step, the automation server also trigger a reboot on the terminal. So the terminal will reboot and get the fixed IP address, and also will change the name of the terminal on the last step. So let's recap those steps. So the terminal boots up and requests a new name, which is a common, a regular name using one of the process of SUSE Manager. So after this name was received by the terminal, it registered on the SUSE Multi-Linux Manager, and it fires some events. So we intercept the specifically the hardware profile event, and the reactor fires automation on the automation server, and then the automation server consults the formula data for the branch of this new terminal, and then this automation can reserve a new name for the terminal. Okay, and as a final step, the automation server schedule DHCP state on the branch server, and later schedule reboots on the terminal. Okay, so it's here is an example of the data that is manipulated by the automation server. It gets a sequential fixed IP address from the static key IP address range on the formula data, and it reserves a new name and a new IP for the terminal MAC address. So let's see on the video this process occurring. Okay. So first of all, I'm showing the environment. We have a SUSE branch, and also the SUSE build machine, and we can see the formula for the branch server, and there are the network configuration, the dynamic IP range, and then layer we have the records for static IP addresses. You can see that we have no static IP yet. So we are booting a POS, the first POS for this store. Okay. So the main idea is that the POS will get one PXE image, and then it will register on the SUSE Manager server. Okay. So let's get forward. Okay. Let's get a little more. So the POS gets the image from the network. Okay, it's downloading the images for the register process. Okay, let's move forward. Okay, so the boot is finishing, and then the POS is already registered on the SUSE Manager server. You can see it here with a standard name from HW type. So we can see that some events are triggered by the SUSE Multi-Linux Manager process. So you can see the hardware list refresh scheduled by the system. And then the reactor will get the completion of this job to fire the automation. Okay, so let's move forward. So here we can see that the hardware profile was completed. Okay, so it's a completed event here. Okay, so we can see that reboot was scheduled by the admin user, and also we can see on the branch server that the the formula was manipulated by the automation. So we have one reservation for the POS 01. It gets the first IP on the static range. Okay. So we also can see on events that DHCPD was scheduled by admin. It's because the automation manipulates the data uh, in the formula using SUSE Manager API, and then later it schedules a state to persist the data, the formula data on the branch server, right? And then later we can see the name of the POS. It's localhost. It's not using the name. Okay, so we can fast forward. Here we can see that the reboot event was taken by the terminal. Okay, so it will reboot and send a post for all the users, and you can see at the minute 14 that the server reboots. Okay, the server will reboot on. Okay, it reboot, and now it will use the image that is already on the disk. It will ignore the PXE process, and then we can see that the boot process is completed. Okay, so I will get one terminal inside the POS system to show you the new host name. So the new host name is now RAD0001, and we can see also on SUSE Multi-Linux Manager that the name was changed. Okay, so this is the process. So let's get back to our slides and let's see the files for this to happen. The files are is the changes on SUSE Manager. What is very simple. You have to configure one reactor inside ATC South master.d. Okay, so you need to create an conf file with reactors like that. So we are delivering all the salt events that matches this regular expression, and then layer on this file check events on this state. We check some items, and then we fire an automation on the Suma automation machine. Okay, so we write one Python script that uses the the SUSE Multi-Linux Manager API to change the formula data, to get data from the formula, and also to fire some states. So we are using the SUSE Multi-Linux Manager API to do that. And later, we also we also form a grain to check that we already run this process for this machine. Okay, so the DHCP server.py code, it's a little bit complex, but we'll host on GitHub. Uh, so later you can check. It's very technical to discuss here, but it's a simple code, and then later you can write me or use this code if you need. Okay, so these scripts basically do the following. It gets the formula data for the branch server of the terminal, and it choose a name and IP for the terminal, and then later it's schedule a DHCPD state for the branch server to ensure these changes are applied to the branch server, and then it's schedule a reboot on the terminal to apply the new configurations. And also, every time that the the code manipulates formula data, it's it's order the formula data by the host name and by the IP order, the static key IP range order. Okay, and it can select the next available IP, but if a terminal is removed from the data from the formula data, it gets the next slot. For example, if we had three terminals and the terminal two is removed, the script will assign slot two to a new terminal instead of leaving it vacant. This is beneficial for retail because there are some machinery replacements, and also the uh, a store needs to rearrange the terminals inside the store. So maybe the user needs to change a name, for example, to get the POS 4 to be the POS 2, for example. So this is the way that they do. Actually, they remove the terminal 2, and then uh, uh, later they do a new they remove the terminal 4 and then do a new boot on the terminal 4, and in the next time the terminal 4 will be the terminal 2. Okay, so the complete code and also the code of the HCP server automation is here on this repository on GitHub. You can freely use it. Also, we host the complete demonstration video on GitHub, so you can see the complete video layer. And if you need something, you can ask. Feel free to ask to reach me by the GitHub issues, or also send me one email. Thank you for your time. I hope you enjoyed this session. I hope I was not so technical, and you can get the idea, the main idea. Okay, so thank you. Enjoy SUSECon 2025.